All right, so this is section 5.5, video number 2. We're going to do the first of these two former AP problems. I'm not going to run through the second one. We might use that one later as some kind of a review problem. But feel free to go ahead and do it yourself if you would like to try. All right, this first one is from the 2004 Form B. This is number 3. At that time, number 3 was a calculator problem, so we will be using our calculator on this problem. So it says a test plane flies in a straight line with positive velocity v of t in miles per minute at time t minutes, where v is a differentiable function of t. Selected values of v of t for 0 is less than or equal to t is less than or equal to 40 are shown in the table below. So the table gives us t in minutes and our v of t in miles per minute. All right, so it's very important. There's a lot of information that's written in that very first sentence, which is really important. And it really just does take experience in reading it carefully to be able to pick everything out. First of all, it says a straight line. That is what it is. I mean, a plane we know is not going to fly in an exact straight line, but whatever. But it says it's got positive velocity t, so the velocity doesn't go negative according to this, which makes sense because you can't really, well, I guess you could have negative velocity if you turned around and flew backwards, but planes aren't going to fly backwards. In miles per minute, so at least the units are consistent. And it says v is a differentiable function of t. Okay, that's really important that it tells us that v is differentiable. Because if something is differentiable, that implies continuity. And we can probably use that, which means if it's telling me that v is differentiable, that means that it's continuous, the velocity is continuous, there's no breaks or holes or anything. Also probably means we'll probably have to do something with the acceleration at some point because it's telling me it's differentiable. And then selected values of t are given, so that's obviously not every possible value, they just took it at specific time intervals. So the first part, use a midpoint Riemann sum, so we're doing rectangles, with 4 subintervals of equal length and values from the table to approximate the integral from 0 to 40. Show the computations that lead to your answer. That's important because you can't just plug it all into a calculator and just write the answer down. Using the correct units, explain the meaning of that integral in terms of the plane's flight. So they also want an explanation of the meaning in context with the problem. All right, 4 subintervals, equal length. The time goes from 0 to 40. So dividing that by 4 means I want 10-minute intervals. So I want an interval to go from here to here, and then from 10 to 20, and from 20 to 30, and then from 30 to 40. So I've kind of already drawn in the bases of the rectangles, if you will. It wants us to use the midpoints. Well, between 0 and 10, 5 is the midpoint, but we're looking for the height between 0 and 10. So at 5, the height is 9.2. Between 10 and 20, again, the base is 10, the height is going to be given from the 15 value, which is 7, and so on. Then at the 25 value, and then at the 35 value, those are going to be my 4 midpoint heights. So we're going to go ahead and write that out. So the integral from 0 to 40 of v of t is going to be approximately equal to, because we're using approximating rectangles, 10, because that's the base, times the sum of all my heights. Oops. 9.2 plus 7 plus 2.4 plus 4.3. And then again, this was a calculator problem. So we're going to go ahead and bring up the calculator just so we don't make any silly mistakes here. So we're going to have 10 times 9.2 plus 7 plus 2.4 plus 4.3, and we get 229. Oops, 229. It does say to use correct units. Okay, so we just accumulated the total amount of miles, because what we did when we integrated velocity was we went back to a position function. So we're now just talking about a specific number of miles. So that is in miles. That would most likely get us a point just by writing that unit. And then it says explain the meaning of what that means. So that means from time 0, oops, forgot to write time, from t equals 0 to t equals 40, the plane traveled 220 miles. And it's important that you write what time frame this was on. You can't just say over 40 minutes. They specifically want to know that it was the first 40 minutes or from time 0 to time 40. Because the plane obviously was traveling past 40 minutes, because if it wasn't traveling past 40 minutes, then at 40 minutes, its velocity would be 0. Okay. Based on the values in the table, what is the smallest number of instances at which the acceleration of the plane could equal 0? On the open interval from 0 to 40, justify your answer. Okay, so it's usually pretty easy to figure this out as long as you have somewhat of an idea. Acceleration is the derivative of velocity. So we are looking at the slopes of the velocity, or basically, where is the velocity going to be increasing to decreasing or decreasing to increasing? And it does say from 0 to 40. So it looks like the velocity goes from 7 to 9.2, so it's increasing, to 9.5, still increasing, back down to 7, so that means we've had a change in the direction of velocity, so that means the acceleration has to have been 0 at some point, so there's at least 1, and still back down to 4.5, then down to 2.4, still at 2.4, but then it starts to go back up again. So it looks like from the chart, the velocity, the acceleration has to have been 0 at least 2 times. It could be 0 many, many other times in between these values. We just don't know. But the smallest number of instances seems to be that it would be twice. So, based upon the table, what's the smallest number of instances at which the acceleration of the plane could equal 0? All right, so we would say the smallest number of instances the plane or the plane's acceleration could be 0 is 2, because. Now this is where you have to use some of the information from above, because v of t is differentiable which implies continuity the intermediate, whoops, I'm not trying to erase, I'm hitting the button on accident. Intermediate value theorem applies since v prime of t changes direction on, let's state the actual intervals. So someplace in between, let's see, goes increasing up to 10 and then back down to 15. So someplace between the intervals of, let's just say 5 to 15. And let's see, the next interval would be someplace in between, let's just say 20 to 35. So we know it's got to occur someplace in those intervals. So that one's more wordy than the other ones are, but you do kind of have to make sure you cover all your bases. So you got to state the differentiability implies the continuity. You got to state the intermediate value theorem, which is the one that says that the all the values in between two values are going to occur, and it's the values of v prime, which is the acceleration. You could have just said acceleration also, but you want to make sure you mention the intervals 5 to 15 and 20 to 35. A lot of stuff there, and more than likely that's probably only worth like a point or something, but in any case it is worth it to write all that stuff out. All right, part C, the function f, defined by f of t equals, I'm not reading that whole thing, is used to model the velocity of the plane in miles per minute from 0 to 40. According to this model, what is the acceleration of the plane at time t equals 23? Indicate units of measure. So what it's telling us is this function right here is used to model the velocity. So basically the f of t, they're calling that the velocity function. Even though we were given specific values in that chart, they're saying that this is the velocity function they're using to model it. If that's the case, they want to know what the acceleration is. So you can obviously take this derivative by hand, but since it's a calculator problem, why? So we're going to say the acceleration is equal to the derivative of f, and so therefore the acceleration at 23 is equal to the derivative of f at 23, which is, now we can just plug this into our calculator since our calculators can do this for us. So let's see here. I want to do a math 8, because that's a derivative. We'll do it with respect to x, even though it says t here, but we'll just use x's, doesn't matter. 6 plus cosine of, let's make it actually look like a fraction, x over 10 whoops, make my trying here, delete, move, there we go, there it is. Okay, plus 3 sine of, I don't know what I hit there. Let me try again. Actually, I'm just go up here and copy it and see what I did there. I don't know what I did there. Let's insert, second, insert, alpha, insert a fraction. Okay, I don't know what I did there. 7x, it's so much easier to do this on an actual calculator than the ones on the computer. Okay, I think that's good. At x equals 23 and negative 0.407. Negative 0.407. You could have rounded that to negative 0.408, and that's fine too. Make sure if you round, you do it correctly. I just like to write the 3 numbers because that's acceptable. It is going to ask, it says units of measure. It's the derivative of velocity, which is something per time again. So that is going to be, what units were we in here? Miles per minute per minute. Now you can write it like that. Miles per minute, or miles per minute squared, whichever one you choose to do. I've seen it done both ways, doesn't matter. All right, and then according to the model F, given in part C, what is the average value of, what is the average velocity of the plane in miles per minute over the time interval from 0 to 40? So this is really the part that matches what we were just talking about. But that's going to be really easy because that is going to be f of c equals 1 over b minus a integral from a to b of, and you do not need to write it out. You can write f of t since it's given, and then we can use the calculator. Yay. So we are going to do alpha fraction 1 over 40 math 9 integral 0 to 40 Probably should have just plugged all this stuff into the y equals screen and used that, but I'll type it back in. Cosine x over 10 plus 3 sine seven x over 40 dx. Average value, average velocity is 5.916. 5.916 miles per minute. And looking at those values, that makes sense because there's nothing that seems to be completely out of range there. So in this case, I wrote miles per minute. You actually didn't need to because it doesn't say to indicate units of measure, and it actually gives it to you right there anyway. But it's never a bad thing to write it. Just double check to make sure that it's actually okay. All right, well, that took us a little over 16 minutes with me doing a full explanation and messing up on a computer calculator as opposed to a handheld one. But you can see how that would be something you could definitely complete within the time frame. And if you didn't get part B, again, I think that was only worth 1 point, so not that big of a deal if you messed up on that one. All right, plenty enough for this one. Again, I'm not going to do the last problem. If you want to do something like that as a review, or if you want to try it on your own, please do.